solve quadratic equations. Okay? And a very important technique that you use. This here is called the zero product. Oh, that's wrong. If A times B equals 0, what's got to be true about either A or B or both? Very good. Okay. If A times B equals 0, then either A or B must be 0, or both. Okay, must be 0, and that's what's known as the zero product property. And we use that property to solve quadratic equations. Say, for example, I had this quadratic equation, x plus 3. I ended up, after I factored something, with x plus 3 times x minus 5 equals 0. Okay? What do I know about either this or this? One of these two things, or both of them, have to be equal to 0, right? So the way I solve something like this, if I end up with this, please write this down, Claudia, okay, is I draw a little squiggly line, okay? And what I do is I say either x plus 3 equals 0 or x minus 5 equals 0. Two possibilities, okay? What does x have to be if x plus 3 equals 0? Negative 3. Now you can solve this algebraically. Subtract, you don't have to, but because it's pretty obvious, but if you do it like that, you get x equals negative 3. Okay? What does x have to be over here? Positive 5. I can add 5 to both sides, plus 5 plus 5, and I get x equals 5. Okay? And that's how you solve something using the zero product property.
So what would you write as the answer?
X equals negative 3 or x equals 5. There's two answers. Two answers. X equals negative 3 or x equals 5.
So does that have anything to do with A times B equals 0?
Yes, because so what Michael said, positives, okay? Unpositive. So if I take negative 3 and put it in here, right, I get negative 3 plus 3, that's 0, right? And 0 times something is going to give, always going to give you 0. And if I were to take 5 and I plug it in here, right, that gives me 0 over here. So 0 times whatever 0 times this will also give you 0. So both of these are solutions, okay? So when you have a quadratic, a lot of times you have two solutions, not every single time. Sometimes you have no solution. We'll talk about that. So what you do with this is you set each separate piece equal to 0. So this one might involve a couple of steps. Either this equals 0 or y minus 2 equals 0. And I have to solve these two things algebraically. How do I solve this one algebraically? What do I do to both sides? First, add 5, right? Add 5, add 5, right? And then I get 3y equals 5. Then what? Divide by 3. Okay? Divide by 3. And I get y equals 5 over 3. Just leave it like that. 5 over 3. And over here, slow down. What do I do to both sides? Add 2. Add 2. And I get y equals 2. So both of these things, when I plug them back in will make this equation 0. So if I take 5/3 and put it in here, 3 times 5/3 gives you 5, and 5 minus 5 gives you 0. If I take 2 and plug it back in here, I get 2 minus 2, which is also equal to 0. Follow? Any questions on that? Okay. So now, we haven't really factored anything yet. So this is where it gets a little bit more, involves another step or two. Say, for example, new page. Should I draw with, let's do this kind of paper. the equation. I have the equation x squared minus 8x, x squared minus 8x minus 48 equals 0, okay? So I'm going to factor this to solve it, okay? So the first thing I have to do is factor. Now, if you remember, what we do is we make a little x. What goes up here? What goes up here? Negative 48, okay? What goes down here? Negative 8. Okay, so we have to think of two numbers that multiply to negative 48 and add to negative 8. Who can think of those two numbers? What? 6 and 8? What? Negative. Very good, Izzy. Negative. That was in 9. Very good, Tom. So, Tom said he was right. Negative 12 and positive 4. So what that means is this factors to, okay, factors to x minus 12 times x plus 4 equals 0. And I draw a little squiggly line. So either x equals what? 12, right? Because 12 minus 12 would make this. So I want to really go x minus 12 equals 0. Or x plus 4 equals 0. Which means x has to be what? What will make this equal to 0? Do you want me to solve the problem? Plus 12, right?
Yep.
I just have to add 12 to both sides, plus 12, plus 12. And so I get x equals 12, or x equals what? Negative 4, right? And these are your two answers. So if I take those and I put them in here, okay, for 12, and I put in 12 in here, that's going to give me 0. Now, I don't think they make you do this on your homework, but just so you know, okay, this represents a graph, right? And this graph is kind of a shifted over graph, but what these represent, is where that graph crosses where the x, where the y value is 0. So this would be the point negative 4, and this would be the point 12. So if I were to plug that into my graphing calculator program like I have up there, I would get a parabola that looks something like this, where it goes through negative 4 and positive 12. See that? And I could show, if I brought up my graphing calculator again, I could prove to you that that is true. But I'm not going to do it right now. You could, okay?
You try.
But you could. Not quite ready for you try. Because I want to do one. Okay, Izzy, go sit over there.
Where?
Next to Tom. Because he's a lot more studious than Minute Cello.
Hashtag
What?
Mitchell.
All right.
Squared.
So, we're going to have another problem. So, say we have one like this, 2x squared, or, yes, sir. So, they say solve by factoring. And this adds a little level of difficulty to the problem, okay? I know, but you can't talk a lot.
I still pay attention.
You have a lot of side conversations.
About.
Minus 5x equals 88, okay? Now, this is where people mess up, okay? First of all, you cannot apply the zero product rule until this side is equal to 0. So the first thing I got to do is get that 88 onto the other side. How do I get that 88 onto the other side? Subtract it. So I'm going to subtract, not 18, 88. I'm going to subtract 88 from both sides, minus 88. And when I do that, I end up with a new equation that looks like this. 2x squared minus 5x minus 88 equals a 2, and this isn't so bad. You can sometimes just guess at it, okay? Watch. I'm going to do it. I'm going to factor this way. What are the only two things that will multiply to 2x squared? 2 and 1, right? So I'm going to put a 2x here, and I'm going to put an x over here, because that's going to give me my 2x squared. So I've got that. Now I've got to figure out, when I multiply this times this, and this times this, it's got to make 5, but it's got to multiply to 88. You can guess. Let's do the cross and box, okay? Let's cross, okay? Up here goes negative 1, is it 176?
Yes.
176. That comes from this times this, right?
Yep.
And down here goes what? Negative 5. So people said, how do I know how to do that? Well, first of all, I know that one of them's got to be positive and one of them's got to be negative, right? I also know that they got to be numbers that are pretty close together, because their difference is only 5 apart. So you might try some numbers that are close when I multiply them to 176. What's 10 times 10? That's 100, right? So that's too small, so I'm going to go up maybe from there, and they have to be 5 apart. So how about, and it's got to be even, one of them's got to be even at least, right?
What about 17 times
17 times 12, does that work?
12?
No, because 2 times 7 is 14, right? How about 18 times something?
18 times 11.
18, what's 18 times?
13.
13 times what?
18.
Is it 13 times 18?
No, it's a difference.
No, because that ends in 4.
That is 2
How about 14 times something? 14 times 9? I bet that's it. What's 14 times 9?
126.
Oh, I'm too low. How about 16 times 11?
17 times
16, what's 16 times 11?
16
Ah,
times
that works. So I kind of took you through my thought processes there, right? I said, okay, I know they're only 5 apart, so I'm going to pick a couple numbers that are pretty close together, and they got to multiply to this number up here. So I kind of took you through. I know one's positive, one's negative, and I did guess and check, right, until I finally figured out what they are. And that's the way I do it too.
Mr.
Okay?
Randy,
Yes, sir.
it should be negative 16 and plus 11.
You're right. Thank you, Alec. Okay. He said it should be negative 16 and plus 11, and he's exactly right.
How do you
Now,
know which one's which? Like, why does it matter?
because they have to add to negative 5.
Okay.
Okay? Now, I don't want to get you totally confused, but I want to show them the Indian method.
I think so.
I think the Indian method is good.
This
Okay?
is a great method, you guys.
It's a good method. Watch. Okay?
One of your classmates really
I taught a couple of people this, and it works better. Okay? This is called the Indian method. Why is it called the Indian method?
because it's from India.
Oh, that kind of. Let's call it the India method.
Or you call it the fraction method because then you remember how to do it.
Feel like
So,
it's kind of right.
now what we're going to learn is the India method or the Indian method?
India.
Yeah, I guess it's from India, but those people are called Indian too. All right. So now the way I do the Indian method is I put this number up top, 2x squared in both cases. Okay. And then on the other top, I also put a 2x squared. Tell me if I do this right, Ms. Lindgren. Right.
Yep.
And then down here, I put a little fraction, and I put this down here, and I call that negative 16x, right? Okay? And I put this number down here, and I call this 11x. And it doesn't matter which one you call what. And now what I do, I just cancel things out. What can I cancel out from both a 2 and a 16? I can take out a 2, right? And I could also take out how many of these x's? 1x. So this becomes just on the top an x, right? Because I've canceled out a 2. What does this become on the bottom?
X squared is 8.
Negative h, right? Because I divided away a 2 and I divided away an x. So this factor right here is x minus 8. See that? That's one of your factors. Your 2x squared. What cancels out from here and here? What's the only thing I could cross out? Just the x, okay? And that turns into an x, and that just turns into 11. So here's my other factor, 2x plus 11. And those are my two factors for that, okay? That's the India method. You like that?
You don't have to do the parentheses first, you generally do them last on the.
Yeah. Do you like that better than the cross and box?
Yes.
Yeah, maybe with some more practice you like it. So now that I have this factored out, I write my two little equations. 2x plus 11 equals 0, and x minus 8 equals 0. Okay? And then I subtract 11 from both sides, I get 2x equals negative 11. I divide both sides by 2, and I divide positive 2 by positive 2, and that's a positive 2, let's try that again, by 2, and I get x equals negative 5.5, or negative 11. Over here, I just get x equals what? X equals 8. So these are my two solutions to this quadratic equation. What numbers, when I plug them in here, will make this add up, multiply to 88? And if I plug in 8 in here, I'll get 88. And if I plug in negative 5.5 in there, I'll get 88. Okay? I know that's a lot of input. Let's do a you try. Can we do a you try? Okay, here we go. You try. Only 30 more minutes, Tony was complaining about. We could call downstairs and see. Who said that? You said there's only 30 more minutes left in class. Yeah, maybe we should call downstairs. We could see if they could extend that a little bit.
No.
No?
No.
What time is it? I have selective hearing, so I only hear it when students mutter things under their breath. X squared. So you try x squared minus 12x equals negative 30. What that should be at 12x minus 12x equals negative 36. We're going to give you, did not get this right, this is what you got to do. X squared minus 12x plus 36 equals 0. When I factor this, you might have noticed this as this is a perfect square trinomial, because the square root of this times this is equal to this, but you don't have to do that. You have to think of two numbers that multiply to 36 and add to negative 12, and those are negative 6 and negative 6. So you get x minus 6 times x minus 6, girls in the front, equals 0. Okay? So either x equals 6 or x equals 6. So that's what that one looks like. Okay? If I were to graph this, just guess what? This is a parabola that just exactly crosses the x-axis at one spot, which is 6. See? Okay, so if I were to graph this parabola, that's what I would get, is that thing right there. Or you could write this as x minus 6 squared, if you want. All right. Should we try one more? Let's try. Let me just show you the setup, okay? In your book, you're going to see a problem where they draw a rectangle. Can I draw a rectangle? Hey! What'd you say this time?
They broke her pen.
Don't break your pen, okay? What they do is they draw a rectangle, and then they have little cutouts. Whoops, that's not what I want. They have little cutouts on the sides of the rectangle, little square pieces cut the sides of the rectangle. They look like this and like this, sort of. Okay? And this and this. These rectangles are all supposed to be the same size, but I'm kind of trying. Okay? In any case, what they tell you in the book is that this is a 3. Each square that I cut out from a side is 3, 3, 3. These are all 3 units. Okay? And then they tell you that this side over here, from here to here, is x plus 2. And then they tell you that from here to here is x. Okay? And what they want you to do is, they want you, and they say that the area is 2/88, right? So the reason I cut these sides out, because maybe they're making a box, right? Do you see that if I folded along these lines, that would make a little rectangular box? Hello? If I folded it up? Hello? Okay. If I folded this up, like folded along this line right here, yes? And folded along this line and this line and this line, it would make a box, right? You see that? Anyway, that's not that important. But what you want to do is figure out an expression for the area. If this side is x plus 2, Brittany, if this side is x plus 2, how far is it from here to here, all the way? What's this whole length? What's its whole length? X plus what? Tony? Thank you. X plus 8, okay? Because you have x plus 2 plus 3 plus 3. What would this length be here if this is x? Going all the way across, what would that be? X plus 6, okay? So they want to know how big is this piece of paper if the whole area is 288. So you go like that, okay? Now this involves a few steps. First of all, what you want to do is multiply this through. First you FOIL it. This is a tricky problem. Watch, okay? First you FOIL it. You get x squared, 8x, and 6x makes plus 14x, plus 14x, plus 48, and that is equal to 288. And now I want to solve this, okay? I'm going to erase this line right here. What do I do to both sides before I can solve? What do I do to both sides before I can solve this equation? What do I need to get over here? 0. So I'm going to subtract 288. Subtract 288, okay? And that gives me x squared plus 14x minus 48 minus 288 makes 240, okay? 240 equals 0. Now I'm going to let you try. Who wants to earn a Tootsie Pop? Okay? You try. See you can figure out. So, the answer to this, I jumped ahead here, is x equals 10. Now I'm done recording. Okay? Your homework is, homework.
You're still recording.
Page 538. 2.